Okay, we just got started into talking about an infinite series. When you have a dot 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 at the end of a series or a sequence, it's called infinite. Okay, so dot 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 means it goes on forever. If it doesn't go on forever, it'll have a number at the end. So, if the numbers here progressively are getting bigger and bigger and bigger and bigger and bigger as you go, as you add them up, then their sum is going to either go to infinity, or they might be getting bigger and bigger in a negative direction. So their sum might go to negative infinity. If that's true, then that series is said to diverge. It does not converge. Converge means that it comes to a specific number. When you add them all up, it'll come to a specific number. Diverge means that it's either going to go to infinity or negative infinity, or it'll bounce back and forth between the two, a positive infinity and negative infinity, which means that it doesn't have a sum. There is no sum. Okay? So, if we take a look at it, it converges if as you add the numbers, they keep getting smaller and smaller and smaller. Because what's going to really happen as you go out to an infinitely amount of terms, that number is going to get so small, it's going to get so close to zero that it won't have any bearing on the numbers that you've added previously to it. Hence, we say that it converges. But again, if those numbers keep getting bigger and bigger and bigger, then we say it's divergent. What we really look at is we look at R. R will be the determining factor. If the absolute value of R is less than 1, okay, which really is saying that R needs to be between -1 and 1, but it can't be 0. That's what that's saying. So if it's between -1 and 1 and not 0, then this series will converge. Because the numbers that come next in the sequence and the series will keep getting smaller and smaller and smaller. And soon they'll get so small that they won't have any bearing. If the absolute value of R is greater than 1, then we say that the series diverges and there is no sum. It doesn't have a sum. Okay? So let's go ahead and take a look and see what that looks like. Here we go. Here we go. Here we go. You can find any infinite series. You can find the sum of any infinite series that converges. Remember, it has to converge for you to be able to find it by using this equation right here, which is exactly the same as the one we did before. The only difference is this n right here, we're going to let go to infinity. So in other words, it's going to look something like this. S sub infinity equals a times 1 minus r to an infinitely large number over 1 minus r. Okay? Now, when this ratio is like we talked about, between -1 and 1, when I take it to an infinitely large number, what's going to happen is it's actually going to turn to 0. So as long as the absolute value of r is less than 1, this part as it goes infinitely large will turn to 0, which 1 minus 0 is 1. This is like a sub a over 1, so when we multiply it, we get s sub infinity equals a over 1 minus r. And that is the equation for an infinite geometric series that you need to remember. And you just plug and chug, and it's that simple. There it is, right there. You got it, okay? So, let's see how it works. Let's see how it works. Let's go ahead and take a look at this slide right here. It says, determine whether the infinite geometric series is convergent or divergent. So the first thing we do is check its ratio. Again, if you can't see the ratio, take the second term, 2/5, divided by the first term, 2, which is like 2 over 1, which really is going to be 2/5 times 1/2. That's going to simplify the 2's, giving us 1/5. Is the absolute value of 1/5 less than 1? If the answer is yes, which is true, it is, then this thing will converge. Okay, if it is convergent, we need now to find its sum. No problem. So s sub infinity is going to equal that initial or first term, which is 2, over 1 minus the ratio, which we said the ratio is right here, 1/5. So 1 minus 1/5 would be 4/5. So that's 2 over 4/5 multiplied by the reciprocal, giving us 2 times 5 over 4, right? So 2 goes into 4 twice, which is 5/2, which is 2.5. So this thing is going to approach 2.5. That's what the sum is approaching, is 2.5. Okay? Let's look here and see if this guy has a sum. So we take the second term, 7/5. We divide it by the first term, 1, which tells me my ratio is 7/5. Is the absolute value of 7/5 less than 1? The answer to that is no, that's false. So this thing will diverge because it's bigger than 1. Simple as that. Done. Okay, let's take a look at this one. Oh, we already did that one. Oh, and that's it. Okay, so there we go, folks. Good luck to you. Have a great day. We'll see you later. Bye.